Hi, everyone, and welcome to lesson 6.3. Today, we are going to talk about the 5 properties of parallelograms. A parallelogram is our next quadrilateral that has both pairs of opposite sides parallel. So, not one like the trapezoid, this one will have both. Oftentimes, you will see this little parallelogram symbol to show that something is a parallelogram and thus its properties are true. So, that first property is, of course, that by name, both pairs of opposite sides are parallel. Now, this leads us into talking then about some properties of our angles, because we have the uh, parallelogram Katie shown, and we have angle K, and angles that are consecutive to angle K would be angles Y, and A, because those are the angles that are next to it as opposed to the opposite angle, which would be angle T. So when we talk about parallelograms, right, because of those parallel lines that we have happening, for instance, KA and YT, again, we talked about like with the trapezoids, these consecutive angles are going to be supplementary to each other because same side interior angles are supplementary. And then that would also work for the other set of parallel lines. Angle K and angle A are going to also be supplementary because they're same side interior angles for the other set of parallel lines when KA is the transversal. So consecutive angles for a parallelogram are going to be supplementary, is our second property of our parallelograms. So again, using this information, we know that if angle H is 115, its consecutive angle buddy would have to be 65 degrees because 180 minus 115 would give us 65. You try the second example. What is the measure of angle T? Now, we also have 2 more properties, okay? And going back to the ideal of looking at a diagonal, what happens is we know that this diagonal divides our parallelogram into 2 congruent triangles. Now, why is this? Well, we know that by the reflexive side, both of our triangles share that diagonal as a side. And then we know that based on the parallel lines, alternate interior angles are congruent. So we would have angle DIG congruent to angle AGI. And then that also would be true for the other set of parallel lines, that their alternate interior angles would also end up being congruent to each other on this pair. So by angle side angle, and we have both pairs, we would have those 2 triangles congruent, right? Now, that being true is important to us because that also tells us about the corresponding pieces being congruent, that the opposite sides of our parallelogram are going to be congruent and the opposite angles are also going to be congruent. And again, that's because of CPCTC, because we have those congruent triangles, those sides and their opposite side would all be congruent because those are remaining pieces of our triangles. So those are properties 3 and 4. So again, these opposite angles are going to be congruent to each other. So if angle N is 72 degrees, so is angle L, as well as the opposite sides need to be congruent. So if we're trying to solve for X, we know that the opposite side of EDFC would have to be equal to it. And as we solve, we could subtract 2x from both sides and then add the 2. We end up with x equaling 5. So as we turn to the next page, we see one last example for us to look at together. This time, notice they are telling us about 2 pairs of angles. We have angle K, which is right here, and then we also have angle KCU, which is this angle here. So again, always be careful of what angles they're giving you. In this case, they are giving us consecutive angles. So what we know is that angle KCU plus angle K, our two consecutive angles, have to add up to equal 180. So that's why I always like to look at my picture. Are they next to each other or are they opposite of each other? So we have 10x plus 6x is 16x's, negative 15 but plus 3, is negative 12. If we add 12 to both sides, we get 16x equals 192. And then last but not least, after we divide 192 by 16, we get x to be 12, which is our final answer this time. All right, now, after those few examples, we have a couple for you to try as well. First, find the measure of the indicated angle in part A, and then you are going to set up and solve for x in part B. All right, now, there is one final property to talk about with these parallelograms, and that is that the diagonals of our parallelogram bisect each other. So DM and MB are congruent, AM and MC are congruent to each other. So again, when the diagonals bisect each other, they're actually cutting each other into two congruent pieces. So we're allowed to say that. Now, not all forward pieces are not necessarily congruent to each other, but we do have each diagonal split in half. So in this particular example, in 3, they are giving us parallelogram SCOT, and they intersect in the middle, those two diagonals at point Y. They then give us that S to Y is 5 times 3x plus 2, and then O to Y is 9x plus 46. They want us to set up and solve for the value of x. Well, what they did is they gave us those two pieces of the diagonal, which we know are congruent to each other because the diagonals are bisected, so those pieces are equal. So on this one, do not forget as you start solving to distribute the 5 through. We get 15x plus 10, and then 9x is smaller than 15x. So I'm going to subtract that from both sides. So we get 6x plus 10 equals 46. Subtract the 10 over. 6x equals 36. And when we divide both sides by 6, 36 divided by 6 is also 6. There is an example now for you to try as well, given the value of FD and DH, set up and solve for X. All right, the last part then is a little bit of a review just so we have an organized list of our different properties. Again, to start things off, opposite sides of our parallelogram are going to be parallel. So for instance, AB is parallel to side DC, and then that means the other set of sides are parallel to each other, so AD and BC. Opposite sides are also congruent to each other. So not only would they be parallel, we can also mark on here these opposite sides congruent. So AB to DC, and then AD to BC would be congruent. Opposite angles are also congruent to each other. So angle A and angle C, because they are congruent. And then angle D is congruent to angle B. Consecutive angles, so angles next to each other, are supplementary. So each one is supplementary to two angles. So for instance, angle A is supplementary to both angle B, and angle A is supplementary to angle D, right? These angles and these angles. And then same thing, angle C is going to have to be supplementary to its consecutive angles, B, and then angle C is also supplementary to angle D. Last but not least, our diagonals bisect each other. So they cut each into two congruent pieces. So AE is congruent to EC, and BE is congruent to ED. So these are all properties you are going to want to keep close by and keep this handy dandy list close to use. Our final two examples, again, now that we know if we have a parallelogram ABCD, if they tell you the measure of angle ABC is 110, if we again look up at our list, we know that these two properties about angles can help us find the others. For instance, the opposite angle, angle D, would have to match and be 110. The other two angles then would be supplementary. 180 minus 110 would give us each of these as 70. Example 2 asks us to find the measure of angle RUT as well as the value of y. Well, angle RUT, or big angle U, is here. And the angle measurements they gave us are actually this piece of two pieces, UTR and STR. Well, together, if we add those two together, 58 plus 45 is 103 degrees. And then we know that angle RUT has to be supplementary to that so that it would come out to be 77. On the other hand, y is talking about sides. So again, we want to think about what do we know about the sides? Oh, the opposite sides are congruent to each other. So I know that 3y, the measure of RS, has to equal the measure of u to t, which is 18. Divide both sides by 3. Y ends up equaling 6. Thanks everyone for watching, and we'll work more with these over the next 2 days.